For the last 15 years, Phoenix Temperature Measurement has been actively involved in the design and innovation of temperature monitoring solutions used in the heat treatment industry and other associated industries like the coating industry, the food industry, and ceramics. As part of the solutions that we can provide, we offer monitoring systems that can either travel through your furnace or your oven to give you a product temperature profile. An alternative solution that we can offer is key to the heat treatment industry, and that is the provision of systems to allow you to perform the temperature uniformity survey, which is a key aspect of the pyrometry requirements of both AMS 2750 and also CQI 9 in the aerospace and the automotive industries respectively. Whether you are performing a survey on a batch furnace or a moving or semi-continuous furnace, Phoenix can offer either a through process survey solution using a thermal barrier and a data logger, or an external data logger, as you can see on the slide in front of you now. Obviously, as part of the temperature uniformity survey, we are trying to prove the overall accuracy and uniformity of the furnace technology itself, to prove that we both have accurate and stable heat treatment conditions for the heat treatment process that you're performing. AMS 2750 and CQI requirements are very, very clear and stringent. So it's important that you cover all aspects of the testing to comply with that standard. Phoenix Temperature Measurement has offered and supplied a temperature uniformity survey solution, which I'd like to describe now. Key to that solution, in addition to the data logging technology and the thermal barrier technology we can offer to suit your application, is the Thermal View survey software. The Thermal View survey software has been developed specifically to address the challenges of performing temperature uniformity surveys. It's been designed to allow you an efficient and accurate way of monitoring and surveying your furnace. But it's been designed and implemented to address all of the necessary requirements laid down by AMS 2750 and CQI 9. In today's market, still many customers, many users are using in-house homemade systems with Excel spreadsheets. And we've been told by many that this process means that the temperature uniformity survey can be lengthy and difficult to implement on a routine basis. The Thermal View survey software has been designed, therefore, to make the whole process as easy, efficient, and comprehensive as possible. So there's no need for rework or the risk of non-compliance when it comes to a NADCAP audit where somebody is reviewing the survey data or report that has been generated. What I'd like to do, therefore, in the next video is give you an overview of the temperature uniformity survey software and its operation. This video is complemented by a series of other videos that go into more detail into key aspects of the software as to how to uniquely perform some of the key tasks necessary in the task to allow full reporting and certification and traceability. And I'll allow you to look at those later if appropriate. So let us embark on looking at the Phoenix Temperature Measurement Thermal View Survey software package and how it operates from a top level. As I said previously, There is other videos that go into more detail as to key aspects of the software, which you can review at a later point. On the screen, you will see that the main layout is split into two main sections. One is the graphical representation of the temperature uniformity data, and you can see here that we have 3 test levels that we have run as part of our uniformity survey. The lower part of the screen is what we refer to as the database or the results database section. And here we have a series of tests that have been performed at different times, and you just click on each one of these. So this is where the raw data or the test results data that you have collected and analyzed is stored. At the top of the database, you'll see the location of the database, but you can, if you wish, you can set up different databases in different locations, possibly for different furnaces, and you can then just simply access a unique database for each of the runs you want to do. But let us go back to the main tests that we were running. You'll see the one that is highlighted as blue is the test that we're actually viewing on the screen. Using the database function, there is security measures in the back end of the software that means that there are backups that are also generated for the database. So if in fact there is any risks of problems with the database in the future, you can always go back to these backup files and retrieve the data with confidence. Let us first of all focus on the overall layout of the screen in addition to the graph and the database. On the left hand side you'll see a main menu panel which basically split into 4 sections. One is running the survey, the others is settings associated with the temperature uniformity survey. The third is called analysis. As you would suggest, this is looking and reviewing and processing the data. And the last but not least, the reporting function, which is key to you delivering a report to satisfy your AMS 2750 or CQI 9 requirements. We will look at these in detail later on. The top left hand corner of the software, we have various menu items which have specific functions, and we'll go through those in due course. But let me first of all focus on the graphical data that we're reviewing. What I'm going to do is I'm going to pull the screen down to maximize the viewing area. You'll notice that the graph, as you would expect, has a y-axis of temperature. The units are currently in Celsius, but if we wanted to, we could change the units of temperature to Celsius or Fahrenheit. So you have the flexibility over the units you want to use. The time axis is the x-axis, and this is at the moment runtime from the start of the survey at 0 time. You can, if you wish, also change the units for time of day if that is more appropriate. At the moment, we are looking at what we call the profile zoom, and this is the time period between the oven start and the stop of the process. If I go to full zoom, you'll see that we can also look at the full data, but we can in fact correct the oven start position and the oven end position with these markers within the software. So you've got full control over what data you want to view on your screen at any moment in time. So again, go right mouse click back to profile zoom. If I want to specifically focus on one of the test levels, so for instance, the first test that is performed at 800 degrees, I can perform a very easy mouse zoom, and that will then magnify the view of the data I'm looking at, and I can see in detail how the respective channels match the 3 levels of the tests that I have in my particular run. In terms of the channels, you'll see in the top right hand corner, the data logger that I'm using is a 10 channel data logger, of which I'm using 9 thermocouples because I've got a 9-point survey. But you'll also notice that there is a additional channel, channel 11, and that is this blue trace here. This is actually the trace from the control thermocouple that we've imported into the TUS report. So it shows you that you can complement the data logger data with external inputs from control thermocouples or other sensors using the import feature, which is described in a later video. The channels you can see are color coded, and if I hover over the numbers, the traces are actually made bold so you can clearly see what they are, and obviously they are distinguished by the respective color, so it's easy to identify where they are and what position they have on the TUS frame. Okay, focusing on the TUS levels themselves, here we have our TUS at 800 degrees plus or minus 14 degrees. This is set up in the TUS level feature, which I'll describe in a moment. But you'll notice that graphically we have 3 clear zones. But the first zone is in pink, and this is basically the overshoot search box. So you'll notice that the box starts at 55 degrees below the TUS level that we are performing our survey at. And this is a requirement of AMS 2750. So we are clearly showing you all of the data that we need to include in the TUS report to ensure that we don't get overshoot in the overshoot stabilize zone. The overshoot zone is then followed with the stabilize in gray, and then we have our final TUS time, which in this particular case is 30 minutes in duration. So we can clearly see graphically that all of the data is in tolerance. We can zoom in even tighter if we wish, or in this case I'm going to go back to the profile zoom so I can see all 3 TUS levels simultaneously on the screen. So the question is, how do we go about performing the TUS? Now the first step you probably will take is to actually set up all of the settings for your particular TUS run. So let's start off with, as we've shown on the graph, the TUS levels. So if I click on the settings bar, TUS levels button, it comes up with a dialog box with the parameters that have been implemented on this particular TUS run that we have visible on the screen. You can see that we've set up 3 TUS level temperatures at 800, 945 and 1020 degrees. We've got our tolerances, stabilization times for both stabilize and also the survey. We've got our overshoot search, and this is 55 degrees, our default, but that can be edited if you wish. And also you can, within the TUS level file, you can actually apply a furnace class table against which the analysis is being performed. This is then applied to the TUS data, and in a later video this is discussed in detail exactly what steps need to be made for both existing and to create a new TUS level file if necessary. The second thing you would do is set up your TUS frame. So this is a feature in which you, as part of AMS 2750, you have to clearly document exactly where the thermocouples are positioned on your TUS frame. You can set up different TUS frame schematics, and you can show exactly where the thermocouples are positioned, and you can give a description of the specific location. The notes section will allow you to add any complementary information, typically the working volume or zone volume of the furnace that you're doing the survey on, any other characteristics of the thermocouples, the type of thermocouples you're using, anything unique about the TUS that needs to be documented as part of the traceability requirements of the report. So we've covered the probe locations. Obviously, we allow, as part of the TUS, the ability to apply thermocouple corrections and also data logger corrections. Let's first of all look at the thermocouple correction file. This is where we can set up for the thermocouples that we're using for our TUS any offsets that are appropriate for the temperatures that are being used for the survey. Within the Phoenix temperature survey software, we allow the ability to use all of the data from the thermocouple conformance certificate. So we are using offset values or data across the temperature measurement range of the calibration certificate, not at a single value. This ensures that we are accurately compensating for all correction factors across the whole TUS temperature range, not just at a single value. You can set up the calibration offsets files uniquely for different batches of thermocouple, and you can identify what batch of thermocouple wire was used for the thermocouples used for the actual survey itself. So this correction factor data is applied automatically to the run, and as you can see here in the top left hand corner, we can see with a green tick here that the thermocouple correction factor file has been applied to the TUS data successfully. We go on to the logger correction. The same thing can be set up for the logger. A unique feature within the Phoenix system is that because the calibration data of the logger is stored in its memory, you can set up the correction factor file very, very quickly and easily by connecting the logger to the software. You quickly press this logger correction file import button, and it will take the data from the memory of the logger and automatically set up the calibration offset table. This means there's no risk of interpolation errors or writing errors of you transposing data from maybe a document to a software table. And you have all the traceability associated with the data logger and where it came from. Again, we can see here from the thermocouple corrections applied means that both thermocouple and data logger correction factors have been applied to this dust data, which is again a requirement of AMS 2750. So there are our settings. Now, all of those files can be stored as library files. And if you wish, you can set up what we call a standard settings file. So if you have a unique furnace you want to survey on a regular basis, and that furnace has unique files, settings files that are unique to that particular run, you can set up a single file so that performing the TUS is really simply just a case of picking one top level file, which will then have all of the necessary library files within it with all the necessary parameters you need to perform that TUS. So in practice, there's no replication or duplication of effort each and every TUS trying to put in your parameters over and over and over again. You can just recall the archive library files, and the TUS is then quickly and efficiently implemented. Going back to the database, you'll notice that for the run we're running at the moment, or we're viewing on the graph, in the database table, you'll see that there is a header bar with the respective settings files, and you can see then clearly what settings file, library file has been used in that particular TUS. So you've got all of the traceability easily viewed from the database in one view, which makes life very easy to understand exactly what parameters are being used as part of your TUS. Let us, having set up our settings files, obviously the obvious thing would be to actually run your TUS. You've got your TUS frame in your furnace. You've connected your data logger directly to the TUS with thermocouples The data logger is connected to the software using a USB cable in this case, and we're going to perform what we call a real-time USB run. So I simply press the new survey button, and it comes up with a option whether I'm going to do a real-time measurement. In this case, I am. So I'm going to click on that. I'm not using RF telemetry, but that's an option if you were using a thermal barrier going through the furnace for live data interpretation. I'm going to use the USB, so the data logger is external to the furnace in this case. Click Next, and what we will then see is the new profile or the data logger settings dialog table. And this is where you have full control over the data logger. You can select how it's going to be started. In this case, because we're using a real-time run, I'm going to start it live. You can check or adjust the sample interval. You've got all of the data logger status information clearly on the dialog, and you can determine how many thermocouples you want to use for your TUS. If it's a 9-point TUS, you'd probably turn off channel 10 and then reset the logger, and that would then automatically start the run, and you would see real-time data coming into the screen. At the moment, the software is running in the conventional analysis mode where we've downloaded data from the data logger. But if we were using a real-time run, it would automatically open the telemetry window, and this is where the live data would be shown on the screen. There is another video in the series that shows you exactly how this works in practice and how you can interpret the data when it's coming onto the screen to ensure that you're matching the TUS levels as required. So let's go back to thermal view survey. So how do we do our analysis? At the moment, we've applied our TUS levels to the data, but there is the ability, if you want to adjust the relative position of the TUS levels. In the analysis options menu, if we click on temperature data first of all, I can then, using the right mouse button, click on the various zones, and I can then adjust these to the data. So it's an easy way of matching the relative positions of the 3 zones to the data, so that you're guaranteeing you're within spec and that the data complies with the plus or minus tolerance of the TUS that you want to perform. When you're happy with that adjustment, you right click to lock those in place. So we have full control over the position of our TUS levels relative to the TUS data to give us the most accurate data and interpretation we need. So looking at the analysis, we're in the temperature data view, and as its name suggests, this allows us to see all of the raw data that we have. Let me zoom in to the first TUS level again. And you'll notice that the data is color-coded to match which tolerance or zone you're in within your TUS, whether it's overshoot search, stabilize, or the TUS time itself. You'll notice that we are looking at channels 1 through to 9, which is from our TUS frame. And if you want to, if we click on the top right-hand corner, there is a little icon for the probe location, and that will show us exactly where those thermocouples are positioned. Channel 11, if you remember, is this blue trace, and this has been imported into the software as a control thermocouple, because obviously as part of AMS 2750, we not only need to prove that our TUS frame data is in tolerance, but also the control thermocouple needs to prove that it's within tolerance for the duration of the TUS that we're performing. Probably the most important results section that we can review is the results table. And this is basically showing you a summary of the analytics associated with each TUS level. At the moment, we're looking at the first TUS level at 800 degrees Celsius, but we could choose either the second at 945 or the third at 1020. And this table gives you all of the data you need to prove that you're within the tolerance bands and the acceptable limits of the test that you're performing. So for each of the thermocouples, it gives us things like the minimum temperature, the maximum temperature, deviation from the test level, maximum difference between the upper and lower temperatures, and then over the entire test, same data. And there's also the ability to measure recovery time and also lag time, if that's appropriate for some of the other test standards that we are working towards, such as AMS 2770 for aluminium heat treatment. The last analysis feature is the test frame. And here we have the ability to not only see where the thermocouples are positioned, but if I go back to the full zoom, if I drag this cursor across the first test level, let me zoom in again to give us a bit more clarity. You'll notice that the temperature data will change, and it's color coded as well. So you'll notice that all at this particular point where the cursor is located, all of the thermocouples are not actually yet in the tolerance band of plus or minus 14 degrees, around 800 degrees, so they're in black. So if I scroll across, as those thermocouples enter the acceptable tolerance band, they turn green until all of them are in tolerance. So it's a useful visual aid to show you that everything is working. So at this particular point, all of the thermocouples 1 through to 9 are acceptably within the tolerance bands that we've set up. Okay. Let me go back to temperature data. And again, you can do the same thing on here with the cursor. So you can scroll across. So you can, if you want to, you can see the data points in minute detail at a particular location in the survey, if that's relevant to you. On the graph, if I right click, there are a number of options you can also apply. The things like adding notes, you can add text or temperature data points or time values or slopes if that's relevant. You can therefore describe what you're showing on the graph at a particular point if it's relevant to the findings of the tests that you're performing. Another thing you can also set up is the furnace class. So in AMS 2750, for instance, there is a specific classification against which you are testing your furnace at. And here you can set up within the software the actual criteria of the furnace class values. Now remember that depending on whether it's Celsius or Fahrenheit, these will be different values, and there is not a direct empirical transfer from one to the other. So use unique values as detailed within the standard. You can set this furnace class table up, and you can then qualify or quantify what furnace class your analysis data is complying to. Last but not least, let's look at the reporting, because doing all the analysis is one thing, but actually generating evidence of your findings to somebody else as part of an audit, that is critical. You want clarity, but you want it to be quick and efficient, but also be accurate. In the software, a lot of hard work has been put in to try and cover all aspects of the AMS 2750 standard as to what information is required. So what we try and do is lead the user through this process of documenting the tests to comply specifically with the standard. So anything that is in gray is basically information that's automatically retrieved from the software, and that is generally hardwired from the logger or the parameters that you've set up in some of your process files. But there is going to be also some free text entry information that is necessary to fully describe the requirements of the report. In the report, there is a list of A through to Z of what needs to be included on the TUS report, and we've tried to address each aspect of that list in this dialogue. So you can see there is free entry for things like control instrument tuning constants. If you wanted to put those in, you can include them in. Details about the furnace, the operator, the type of atmosphere that was used, for instance. If I go to next, and if you need to, there is also the ability to add customized reporting fields for other unique aspects of the testing that you're doing, which would complement the test data that you're running. Now, a lot of this information is manually put in. So one thing we've tried to do is to help with the reporting capability. There is the ability to use a template. So having set up your report contents for the first run, and you know there's going to be subsequent runs in the future, you can actually save this data as a template so that when you next do a run, you can create the report automatically by simply retrieving the actual appropriate template that you want to use. Now that template is likely to be uniquely identified by the furnace or the process that you're monitoring, but it's a nice way of automatically setting up your report so that it's consistent run to run, and you don't have to spend significant time manually incorporating text back into the fields that is common from one run to the next. So if I show you quickly, this is just a demo example of a report, and this shows you how much detail there is. So there's all of the traceability information, and then the analysis, the graph of the TUS, example of the TUS frame, and if I keep going down, obviously this is a 3-level TUS, so there's quite a lot of data that needs to be reviewed here. But at the back end, there's also all of the thermocouple correction factor data that was used or applied in the TUS, and also the data logger correction factor data, which is all necessary as part of the TUS requirements. And there's also an audit trail, which tells you exactly what was done as part of your TUS. So hopefully I've been able to give you a little bit of an overview of the level of detail that the Thermal View survey software gives you. But remember, a lot of it has been implemented to try and make your life easy. At the end of the day, efficiency is key when it comes to performing your monitoring requirements. We don't reduce the level of detail or the accuracy of the information, but a lot of the tools and the features that have been implemented are there to help you in that process. Again, remember there are some other series videos that will give you more detail about aspects of the software in more detail if you're wanting to perform those yourself on your software. But hopefully this gives you an idea that if you want to be efficient, accurate, and confident in your temperature uniformity survey work, the Thermal View survey software is there to help.